So we have finished our introduction to normal distribution. Let's see how to use Excel to do some related calculations. So for example here, we have a graph that depicts those normal curves or normal PDF values. So for example, this one, we have this blue curve. The blue curve is a normal distribution value PDF with mean 10 and the standard deviation 2. Okay, let's try to see how to get PDF values from Excel, and let's see whether we may verify whether these values are right or wrong. So we can see that when we want to do this, then we're talking about possible values from 0 to 20. Okay, so how about this? I'm going to get some values from 0 to 20. And I'm going to get a set of values, something like this. How about this? I'm going to just use 1 as the interval. Okay, so if I do so, I roughly can get 21 values. Okay, and then they are just integer values between 0 and 20. For each value, I want to use this function, norm.dist. I want to ask myself, what's the PDF value? What's the probability density for 0 when it is with respect to a normal random variable with mean 10, standard deviation 2, and now let's focus on the last argument. In this argument, cumulative means if you want to get the cumulative distribution function, you want to get the CDF, then put 1 here. That means you are talking about cumulative distribution function. Or if you put 0, that means you want to talk about 0 means false, okay? And that means you want to get a probability function, probability mass function. Here it put mass, but anyway, you know it just means density. Okay, so I'm going to put 0 here, and that gives me a very small value. Anyway, I'm going to double click and get some values that like this. No, wait a moment. Now I don't like scientific. So I'm going to put my values back. Okay. So anyway, let's see, for example, 8. For 8, I get about 0.12. For 8, roughly 8 is here. I get to this blue curve. I get about 0.15. 0.15, 0.12. Okay, for 9 is roughly here. I get almost 0.19. Somewhat makes sense. Okay, so what I may do is that now I may just draw a line chart from it. Line chart is here. We can see a curve, not very beautiful, but roughly it is the same as the curve that we may observe from this PDF. Okay, we can see that this blue curve, the top is around 0.2, which locates around 10. So here we can also see the top is around 0.2. This is 11, and that's because we did not decorate our line chart to make it start from 0. If we do that, then basically we can fix that issue. Okay, we can see indeed we get 10 to get the highest value, highest PDF value. So of course, if we want, we may make it more smooth like this. So maybe I want to just use 0.1 as the interval. So that means I need to do a lot of function invocations here. And then I want to scroll down to very far. Okay, should be enough. So now I want to reselect my range here. I want to get to, for example, here, okay, 26. And if I do so, I'm going to see a very smooth curve here, and it just looks like a beautiful bell shape. And we can also see that, wow, indeed, it is just almost identical to the curve that we observed from the slides. So how about we get the green one? Green one is also easy to get. All we need to do is to change the standard deviation to 1.5. So let's try it. Here, everything is with about 2. So let me change it to 1.5. And then I want to remove everything. We get another curve that is just tighter in some sense. And the peak is about 0.26. 0.26, right? So lastly, I want to get the the red one, 12 and 1. So let me try it. 12 and 1. We can see that it's going to shift to the right. And the top is about 0.4. Top is about 0.4. Makes sense. What's more important is that given a normal random variable and given a cutoff value, we need to be able to calculate the cumulative probabilities up to that cutoff value, or starting from that cutoff value and move to infinity. We need to either get the left tail probability or the right tail probability. Anyway, we need to deal with that cumulative probability. So how to do that? Basically, we just need to use again that NORM DIST function. And all we need to do now is to change from PDF to CDF. So very quickly, let's see how to do it. For example, here, I have a normal random variable whose mean is 25 and the standard deviation is 5. Okay, how about we start from a cutoff value that is 15. So now we know how to do this. We have NORM.dist. I want to check up to 15. What's my values if my mean is 25? Standard deviation is 5. And now I want to talk about cumulative. Okay, cumulative. Then I get about 2.2%. And we can see that indeed this is roughly 2.2% because here I have two parts. And then for each part, I get about 2.5% according to this rough value. And now we see it's actually 2.2% or 2.3%. So one thing to keep in mind is this one here talks about left tail probabilities. If you want to get right tail probabilities, you use 1 to subtract this left tail probability. So for example here, if I want to calculate the probability for x to be greater than 35, how to do that? I put 35 here, and then I get some value. This is the probability for your x to be less than or equal to 35. So if I want to get the value for the x to be greater than or equal to 35, I should do 1 minus that, 1 minus this one. Okay, it's again 2.3%. So that's how we may get this particular outcome in Excel. It's good if we understand the theory, understand PDF, CDF, whatever, but if we don't, at least we know how to use Excel or other software to calculate those left tail or right tail probabilities for normal distribution. Here we also have some kind of standardization thing. So let me quickly do one exercise here. I have x, let me write it down. I have random variable x, and its mu is about 100, and its standard deviation, or let me call it sigma, is 20. Okay, for this particular x, I want to ask what's the probability for x to be greater than or equal to 140. What's the probability for x to be greater than or equal to 140? And I hope you know how to do it. So NORM DIST. So my x is 140. Mean is here. Standard deviation is here. And in any case, I'm going to put 1 here because this is talking about greater than or equal to. So I'm going to use 1 minus that left tail probability. That's 0.227. percent and 0.22. So I have another thing. I have y here. For y is 90 and 10. And this is asking us to talk about y cutoff 110. So what's the probabilities for y to be greater than or equal to 110? Well, nrm.dist, and then 110. I have 90 here. I have 10 here. I have 1. Again, all I need to do is to use 1 to subtract that. I get exactly the same value. And here, we may also double check what's the probability for your z, for your standard normal variable, to be greater than or equal to 2. In this case, there are two ways. So either you put 1 here and 0 here, and then you ask yourself what's the probability for z to be greater than or equal to 2. 1 minus norm.dist. We have 2 as the cutoff value, 1 here, 0 there, cumulative 1. I'm sorry. So where I did wrong? Oh, sorry. It should be mu 0 and sigma 1. Okay, so you can see they are the same. Makes sense. And also because standard normal is so important, so Excel even has a function that is specific for standard normal, norm.s.dist. We can simply enter a z value and then say we want cumulative, of course. And then again, we get that CDF directly. So this is how we may use Excel to do some calculations with PDF and CDF for normal random variables.